guys aren't keeping those. I will give them to you for you to look at. If you got under 70%, you will work on corrections in study hall. Okay, next week most likely is when you start working on those corrections. For right now, you have a quiz tomorrow. Okay, the quiz is open note. It covers exercises 11 through 14. So if you can do exercises 11 through 14, then you're good to go on the quiz. So that's what the quiz tomorrow will cover. Exam, you can do corrections starting Monday in study hall. Okay? Yes? You have the notes. You got to stay caught up according to the campus schedule and the schedule I gave you at the beginning of prep. Huh?
Did you miss Thursday?
Last Thursday. You took the exam.
No.
I thought you meant just what did you miss the last couple of days. Yeah, the stuff you missed, you just got to go through the notes and catch up that way. Okay? Mobility. Micah.
Like it's not written down.
Micah. Okay. So last night you were supposed to finish exercise 13. Maybe 11. We're going to go over your exercise 13 real quick. You're going to check yourselves. Okay, if you're not getting the homework done, meaning you're just having us do it for you, okay, like, and you're just like barely doing anything right now, there's a problem. You're not going to do well. Okay, those of you that, I mean, you've got to put in the right time and effort to do well. Okay, so if you're not putting in your own effort and giving it your best effort, like yesterday we had 20 minutes to do exercise 13. Everyone should be done with exercise 13. You had time in class to get that done yesterday. Okay? So you should have something on your paper. Does it have to be right? No. That's why we're going to go over it, so you can check yourself and say, okay, this is where I messed up. So we'll go over that, and then we'll cover some notes, and we'll do exercise 14. Hopefully we'll have some class time to do exercise 14 in class today. Okay, so this is what you had to start with yesterday. You have to show that this statement is either valid or not valid, right? Okay, if it's valid, that means the conditional statement here will be a what? Tautology. So, let's look at, let's see if I can pull up the answer key here. Mine's slightly different. Okay, here's exercise 13. Okay, so if you have a true, 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 the row of true, 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 okay, should be a true, 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 false, false, true, true. The row that you have true, true, false, okay, so again, if you, some of yours might be different than mine if you didn't do this order of options. Okay, we're going to go through each option real quick. So on your true, true, false row, you should have true, false, false, true, false, false, true. On your true, false, true row, you should have false, true, false, 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 true, and a true. On your true, false, false row, you should have a false, true, false, true, false, false, and true. False, true, true row, a true, a true, a true, false, true, true, true. your false, true, false row, you should have true, false, false, true, 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 true. So if you weren't here yesterday, it's not a good idea for you to go fill in the blanks and never look at this again. Does that make sense? So if you haven't been here the last couple days, you need to make sure you're not just filling this in, because it's not going to help you at all. Okay? It will not help you other than now you got the right answers. Great. Okay? You need to make sure you understand how to fill in the table. Okay? Next, false, false, true row. We have a true, 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 false, true, true, and a true. Okay, our last row, false, false, false. You have a trues all the way across. Okay, questions on that truth table? Yes?
I think it's funny that the false, false, false is all true.
Yeah. Yeah. Okay, so is this a valid statement?
Yes.
Yes. Valid argument. Sorry. It's a valid argument, right? Because we have a tautology right here. These are all true for our argument. Okay. So this is where we're at. It's going to just be more of the same thing really today. Okay, a lot of the same thing. Let me pull up my notes right here. Okay, we're going to check the validity of the following argument. Okay? If 2 plus 2 equals 5, then 12 is a negative integer. What's 2 plus 2 really equal? 4. 4, okay. So if 2 plus 2 equals 5, is 12 a negative integer? Let's see. Is 12 a negative integer?
It could be.
Come on, is 12 really a negative integer though?
No.
No, it's a positive, yes?
Yes.
Okay. So, 2 plus 2 equals 5, therefore 12 is negative integer. So this is what we're going to work with here for a second. So P is our statement, 2 plus 2 equals 5. That's our statement. Now, we don't, is this a true or false statement? Okay. So let Q be the statement 12 is negative integer. The symbolic form of the argument looks like this. So if P then Q, right? Good? Okay? And then if we look here, P1 is the first premises, okay, or our hypothesis, right? Okay, the statement if 2 plus 2 equals 5 and 12 is a negative number, P2 is the second premises. Let's see how we want to actually word this. Let's do this. Let's write it this way. Let's look at this whole thing. So, we're going to take this argument and we're going to symbolically represent. So we have P1, a P2, and C is Q.
Okay.
Okay? So premises 1, premises 2. So that's what, okay, right now, right off to the side of P1 right here, say premises 1, in parentheses, premises 1, premises 2. Okay, we're going to use this. You guys know when we do, let's just scroll this down here real quick. Okay, we're treating this as, let's say if we have 12 plus 7, that's 19, right? Okay, you guys, we have premises 1, premises 2. This is kind of like our equal sign. You know how this symbol right here is like our equal sign? Yeah, that's how this is kind of set up. It's kind of like a math problem here. But we're not going to do that. We're just kind of, I'm just helping you guys recognize what they're doing with the writing here. So now, if we say P1 is our premises, P2 is our second premises, and then our conclusion is Q.
Okay.
Okay, so what we're going to do with this is we're going to make a conjunction of these two statements. So if we make a conjunction, we have if P then Q, as a conjunction with P, that is going to give us Q. Right?
Yeah.
Big arrow, sorry. Big arrow. So look at this, how this is written on your paper here. have it written right here. So all this is saying is, let's take these two values and make a argument. So, if we look here, we're saying we start up here. Okay, we have our P1, P2. Conclusion. P1 is the first premise, P2 is the second premises. The argument states that the conjunction of these two premises implies the conclusion. So if we take our P and Q, okay, remember P is what? 2 plus 2 equals 5. If 2 plus 2 equals 5, then 12 is a negative number. Okay, so this would be a false, yes? Which is true. Okay, so, and as a conjunction with P, this is going to be a false, yes? Okay, and that implies a false. So, this would be a true conjunction with a false, yes? You guys following? Okay, a true conjunction with a false, and then a false. Okay? Let's see if this makes more sense. Maybe better this way. Argument is. Give me 1 second, guys. Trying to think of a better way to explain it. Let's make a table. So if we know,
Are you explaining why it's
we're gonna make a truth table. Then that hopefully that'll explain what we need here. So look, if we have a P and a Q, we have if P then Q. Everyone write this down off to the side of your paper here. Okay? And then we're gonna have if P then Q as a conjunction with P. And then we want the whole statement, if P then Q, as a conjunction with P, and then this would be Q. We might not use it for this one. Sorry, this isn't working out. Okay. So if we read right here, this argument is valid by rule of modus ponens shown in example 14.3. You guys remember all the big list of rules we had yesterday? Okay. So look at our statement here, our argument. See our argument? It's highlighted. Okay. We're going to come back up here. Rule of modus ponens is this guy. Right? So, we know these are facts. We talked about theorems being our facts yesterday, right?
Yeah.
So these are our facts. This has got to be an implication every time. Okay? This is a valid argument. No matter what, this is always going to be a valid argument because the facts tell us so. Okay? It's going to be a valid argument. So, if we come back down to the example here with 2 plus 2 equals 5, then 12 is a negative integer. Okay? If we make that as a conditional statement with a conjunction using the rule of modus ponens, we're going to say it's valid. Okay? We're going to check this with example 20. Okay? We're going to use example 20 here. So check the validity of the following argument. We're going to use this one instead of the 2 plus 2 one. So 2 times 6 is 12, yes, everyone?
Yep.
Then 23 is a positive integer. Is 23 a positive integer?
Yes.
Yes, it is. So P is the statement, 2 times 6 is 12. Let Q be the statement, 23 is a positive integer. So if we were to take these statements, assign them truth values, Okay? So we know that P can be true, true. Or and so true, false, false, true, and false, false. Okay? We know that this is going to be true, false, true, true. Okay? If P, then Q. Okay, that's going to be true in this case, so we have a true with a true. Conjunction, yes? What's conjunction true?
If both the values.
Okay, so here we have a false and a true, so this is going to be what?
False.
Okay, a true and a false.
False.
True and a false.
False.
Okay, come here. Now we have another conditional statement. So our conditional statement, we're saying we're going to use this as one statement and Q as the other. So if I take true and true, that's going to be true. False and false. Oh, sorry, I wrote it F. Sorry, that's true. False and false, that's true. False and true, that's going to be true. False and false, that's true. So this shows you that the rule of modus ponens always works. Okay, so if you have this statement, it's always true. Okay? So if we look at our example here, we know that this is true and this is true, yes? So they're both true. Q, P, and Q are true. So we're essentially modeling after this row. Okay, if we go back up to example 19, 2 plus 2 equals 5, and 12 is a negative number. So if we look at this one, where here we have both P and Q are false, yes?
Yep.
So in this case, if both P and Q are false, we get true in the end. Okay? Because our P's and Q's for example 19, they're both false. We end up true. Yes? Right.
So is this are we doing this example 19 or 20?
Both. This table works for example 19 and 20. So if we use this for example 19 and 20, because example 20 says, look, they're both true, yes? P and Q are both true in example 20. We end up with a true statement. P and Q are both false in example 19. We end up with a true statement.
So on the bottom of example 20, it says this argument states that
Yep.
and it has an Q instead of P.
Oh, whoops, I got the wrong table for that. Well, this works for example 19. Sorry, just did 19. This one's just 19. So let's do example 20 table. So if we use example 20, make another table for example 20. We have P and Q. If P, then Q. And then we have if P, then Q, and Q. Okay, if P, then Q, and Q. And then we have if P, then Q, and Q. That's going to be a conditional statement with P. Okay, let's do the same thing. We're going to make a table for this. Okay, we're going to see if this statement, if this argument is going to be valid. So now, in our case, we're always going to have a true, true, false, true, or sorts, I did that out of order, true, false, false, true, and false, false, yes? Yes, good? Okay, if P then Q, that's going to be true, false, true, true. Okay, now we've got if P then Q as a conjunction with Q. So the conditional statement of P and Q as a conjunction with Q. So conjunction here with Q, when's a conjunction true?
Both of them are true.
If both of them are true, so we have true and true. True. False and true, which means, okay, true and false. True and false.
False.
Okay. You get the same table though?
No.
Same table?
Yes.
So far it's the same. Yes?
Yes.
Okay. True and true means that's going to be true. False and true, that's true. False and true. Oh, sorry, this is false and false.
Which is true.
False. So this is P. We want to look at P. So false and true. Yep. False and false. That's true. False and false. That's true. So the only thing that changes is what you're looking at in each one. The tables here are the exact same. It depends which one you're looking at, though. Here we looked at our Q in this particular column, and here we're looking at P in this particular column, whereas we were looking at Q here before. Okay? The tables here are the same, but different because they're different statements in the last two columns. Yes?
So if the statements on example 19 and 20 are true, how come one is valid and one's not?
This is for example 18. Ignore this right here. In example 18, it was shown that this argument was not valid.
Okay, got
Okay, so right now we all on the same page?
Yeah.
Fill in the table, tell me it's valid. That's really same thing as yesterday, right? Okay, let's look at example 4 or exercise 14. You guys don't mind getting it done in class, right?
No.
Not at all. It just says use symbolic representation to check.
What?
It says use symbolic representation to check the validity of the following argument.
Say it louder for me, but
It
sorry.
says use symbolic representation to check the validity of the following argument.
So meaning what?
Just make a symbol of it.
Okay. We're gonna make a truth table still too. That's gonna be part of our symbols. Yes. Yes, that's what we're going to. Yep. Perfect.
So I got it right?
That part, yes. Okay, so on exercise 14, if it rains, then the soccer game is delayed. It is not raining, therefore the soccer game is not delayed. So we need to assign, we're looking at the whole argument, I guess, is what we need to go back here and look at. So on exercise 20, okay, the whole argument is all three lines, okay? So we need to look at all three lines. If 2 times 6 is 12, then 23 is a positive integer. 23 is a positive integer, therefore 2 times 6 equals 12. Okay? So we're checking the validity of the whole argument, all three lines. If you guys look at what we assigned here, we said, look, P1 is basically line 1, P2 is line 2, and our conclusion was line 3. When you see therefore, or since, or in conclusion, or consequently, that's usually leading into your conclusion in an argument. Okay, when you hear those words, those should be like red flags to say, oh, my argument's ending, it's coming to an end. So the end of our argument here is 2 times 6 equals 12. Because if 2 times 6 equals 12, then 23 is a positive integer, and 23 is a positive integer, therefore 2 times 6 is 12. Okay, so it's all three lines are part of the argument. So if we go to exercise 14, what is P1? What is P1? If we're following that same kind of pattern, what's P1?
What
be, wait, are we, okay, yeah, we're talking about this one. So, would it be, if it rains, then the soccer game is delayed, then it is not raining?
Yep. Well, no, so then the soccer game is delayed. So P1 is just going to be the first line. Okay. So if it rains, so let's just do this. Write down it rains. We're going to assign that just the value of P. Okay. So we're going to do P's and Q's. So we're going to identify our arguments, our statements. Statement 1 is it rains. Statement 2 is what?
It does not
The
rain.
soccer game is delayed.
The soccer game is delayed. So write these down. This is exercise 14. So we're getting our homework done. Okay? Now, what's the negation of P?
It doesn't rain.
It is not raining, right?
We should be writing this down.
Or it doesn't rain, it's not raining. Okay? Same thing, right? Okay, something with not raining. Okay? Yes? Okay, so we want not Q. You're saying the soccer game is what?
I'm saying that not Q should be the soccer game is delayed, and Q would be the soccer game is not delayed. Oh wait. Oh wait, never mind. Sorry.
You're okay, you're thinking the right way.
My brain died.
No, you're okay. You're doing the right thing. As we make inferences and we say, okay, maybe I'm not right, or maybe I need to rethink that. That's fine. Okay? So we see all of these in here, right? You guys see all the CP, CQ, see not P and not Q? The premises, though, okay? Maybe we should use a different letter other than P so we're not so confused. Let's use, would it be better if we use R here? Maybe? Let's use R and not R, okay? Let's just rename these statements as R and not R. Okay, because we're going to use P1 and P2 as premises 1 and premises 2. So our premises 1 is if P, then Q. You guys see that? It rains, if it rains, then the soccer game, R, thank you. Okay, so if R, then Q. You guys see it?
Yep.
Okay, so if it rains, then the soccer game is delayed. Good. Premises 2 is it is not raining, which is not R. Okay, good. Therefore, the soccer game, okay, we got our dotted line. Okay, remember how we did this on example 19 and 20? Had premises 1, premises 2 gives us a what? A conclusion. Good. That's going to be, what's our conclusion?
Not Q.
Not Q. Okay? So if we write this out symbolically, we have if R, then Q. Now what? Huh? And not R. Good. And not R implies not Q. Our goal is to see what? The validity of the following argument. Okay, so let's make our truth table. That's how we check validity, right? So we have R and Q. So we know we're going to have a true, 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 false, false, true, and a false, false case. You guys have lots of paper there, right? So you can write the table down, hopefully. Okay, what other values do we need to know?
Not R.
Yes.
If R, then.
We're going to need to know an if R, then a Q. Okay, what's another argument or another statement we need to take truth values on? Yes.
Not R. If R, then, well, we need not R.
We need not R. Okay, what's another statement we need?
Not Q.
Okay. Who said not Q? Not Q, okay. You gotta raise your hands. So what's the next statement we need? Another statement we need. Yes?
If R, then Q, and not R.
Okay. If R, then Q, and what?
Not R.
Not R. And our last one is our implication turned into a conditional statement, right? Okay, so now we're going to put our brackets here. Okay, if R, then Q, and not R, as a conditional statement with not Q, or not R, sorry.
Not Q.
It's not Q.
It's not Q.
It should be.
Yes, not Q.
It's,
One second. Yes. Not. Okay. Okay. True, true means we have a true. True, false means we have a false, true here. Because this is conditional statement, right? False, false. Not R. Because it's true here, right? So we have a false, true, and then a false. What goes here? True. Why is not R true?
Because R is false.
Because the R here is false. Okay, some of you guys are still learning truth tables, so I'm trying to kind of slow down here. Okay, not R here would mean, oh, it's got to be true because R is false over there. Okay. Okay, not Q. We're going to do the opposite of Q down this column. So we're going to do a false, a true, a false, and a true. Good. Okay, now we're going to make a conjunction of the conditional statement with not R. Okay? So we're going to look at these two columns together. So right here, these two columns. I'm going to point arrows to them. We're going to take these two columns to make the this column right here. And our conjunction column. Okay, when is our conjunction true again? If both are true. Yes? Okay, so what's the first blank?
false, false.
False.
True. True.
Good? Okay, let's do the next one. We have this statement from the previous column, our conjunction of if Q then R and not R. Okay, we have this conjunction statement as a conditional with not Q. So we're going to look at this column and not Q. So we're going to match these two columns together. Okay, if we have a conditional statement, and the conditional statement is false, false, what do we have?
True.
Then a false and a true. A true then a false? A true and a true? So is our statement valid?
No.
No. Why?
Because it's false.
Yes.
It's not a tautology.
It's not. So we'd say, since,
You have to write proof on top of it, don't you?
that would be nice. Since our conditional statement of if R then Q has a conjunction with not R, makes a conditional statement with not Q, is not a tautology. Tautology. Have to work out that word a little bit. Then what? What do we conclude? Then the statement is what?
Invalid.
Invalid or not valid, I don't care which one it is. Good job, you guys.
Don't we need that box again?
Oh! Need the box, or you can write QED. We'll just do the box. I like it.
Put QED.
Q.E.D. So you can do the box or Q.E.D. Like that. Yeah, you do the box. The box is much more simple. And it's fun to draw the box and change it. It's just me
Can I
and
draw a triangle?
no, it has to be a box.
What about a square?
Nope, it has to be a box.
What about a 3D box?
Draw
Again,
a square.
it has to be a box and only a box.
No, he said that I can't draw a square.
Draw a box.
What does the box mean?
But a square can be a rectangle, but a rectangle can be a square. So technically, a square would be a box.
What's the not symbolic representation?
A square is a qualification.
What?
What's the not symbolic representation that we can prove?
If you were to put this all in words, so that would be this.
So it would be
So
not
this
attributed
in
to-
symbolic notation is this. Make sense? And vice versa.
Will this be on the test? With,
I can look.
and if it is on the test, that means you have to do the table also. Instead of just, D1 and W and D.
Okay, all your guys' quizzes tomorrow. Okay? Yes. Okay, I'm gonna tell you how the quiz will go tomorrow. You ready?
Yeah.
Okay. So, you have this truth table to fill out. You see it? Okay? You have 3 questions. Each question's worth 10 points. You're gonna use the truth table to prove a tautology, to prove something is not an implication. So if we're to prove something's not an implication, basically,
There's gotta be a fault somewhere.
so the statement will say something like this. They'll say, look, show it's not an implication. They'll have a line through it like this. Guys, I'm trying to tell you some things on the quiz tomorrow that the questions are going to come to. You haven't seen this little arrow across that yet. Okay, this means not an implication, right? It's not implied. When you see that, they're just trying to tell you, hey, fill out the truth table to show that you're going to have a false here. Okay?
That little arrow means does not imply, then it's when we're doing the, yeah, this is invalid or it's valid, does that mean we can do the 3 dots since, bracket, parentheses, R, then Q, parentheses, and not R, bracket, then not Q, is not couple, we said bracket, parentheses, R, then Q, and not R, bracket, is not implied.
This is a conditional statement. We're saying since this is not a tautology, then you can say, then the statement, you can take this statement, put it here, comma, put it here, and cross the line through it, if you want.
Is valid.
These are 2 different things. This is our implication, this is our conditional statement, yes?
Yeah, so you're saying,
I'm saying you can move this down here and say what you said, and put it right here, since the statement blank, then you could write it like this. You could write this. Then, instead of writing this part, we can write this, okay? So two alternate ways, so you can do this, or this.
Okay.
That your question?
I was just curious, not that I would want to write that one.
No, it's a good question. Good job. Yes?
Did we write arguments instead of tables?
That would be better wording, yeah. Argument. That is more correct, yes. Good, next.
So, when you have it, like a little implies arrow, you just change it to that, conditional statement arrow.
Yep.
And
Because really, they're, depending, because I was researching online, okay? So depending on what you find online, a lot of people will use these as simultaneously as the same thing. But we're referring to them as showing if an argument's valid versus use the conditional statement to show it's valid. So we're going deeper than probably what an online example would give you. And a lot of people, from what I was reading online, will use them synonymously as the same thing. So yeah, so this way we just know the difference. Yes, just kind of helps us with our writing. Yes?
So, back to my statement about the not points. If you want to say, then that statement is valid.
It's not valid.
Well, it's saying it does not.
So if it's not valid, it means that it does not apply. Yes.
Yeah, it does not.
Okay? These mean the same thing. Okay? Okay, let me tell you on your quiz real quick. Okay, the first question, you're going to use a truth table to prove that a statement, okay, a conditional statement, is a tautology. Then you're going to use a truth table to prove that that an argument is not an implication. So really, you just got to fill out truth tables. The third question, you're going to use a truth table to prove that an argument is valid. Okay? So if you can fill out truth tables, you're going to do well. Okay? Trev?
how long will we have for the quiz?
Maybe 10 minutes. Should be all it takes.
Do I have to write the sentence at the end?
Yep.
Okay.
If you're showing an argument is valid or invalid. If you're just showing that a table is a tautology, you just say, since the truth values are the same, or whatever statement it is, you can say that it is a tautology. So, yeah, do some explaining with the sentence.
Is it open book?
Yep. Open book, but not open neighbor. Meaning, keep your eyes on your own paper.
Will it help me?
Right? Okay, any other questions? Yes? Not yet. I'm gonna have you guys look at your test real quick. Okay, people that took the test late, meaning you took it Monday because you were gone. Okay? I don't have yours back yet, so you won't get yours right now. But everyone else, I'm just gonna show you real quick. Okay, to make this smooth and do this in 5 minutes. Okay, it's 12:14 right now. We got 6 minutes till lunch. I'm gonna hand these back. You're gonna look over it real quick, and then you have to, on Monday, if we have time tomorrow, I'll go over the answers with you. But I need these, this is your ticket out here, so you can get them back real quick, look at them, see what you missed, and then you're gonna hand them back on your way out the door. Okay? Tatum. I'm still learning names, so make sure you guys help me out a little bit. Put them up, yeah.